For today, you should have read an article about science talks by Roseberry and Ballinger, as well as Case Study 2 from the Next Generation Science Standards. Please have those articles ready to pull out and look at during this session. This session, Listening and Speaking in Science Learning Contexts, is the third session of Module 2 on Academic Language in Science, a collaboration between the University of the District of Columbia and the Center for Applied Linguistics as part of the Project First grant. This session is focused on oral language production and reception, speaking and listening in science contexts. In this session, you'll begin with a warm-up to help you think about speaking and listening in a science context. Next, you'll discuss what it means to talk science. There are a number of books written on this topic, and so it's important to have an understanding of what talking science means. We'll also talk about a linguistic term used to describe certain types of oral language production, called speech events. After covering the concepts of talking science and speech events, there will be a review of the articles you read for today. Then you'll have the opportunity to participate in a data workshop to practice applying what has been discussed. We'll end with a wrap-up and assignment. In this session, the objectives are to review and discuss information about listening and speaking practices in science learning contexts, to examine specific uses of spoken language in science learning contexts, and to critically think about scientific language practices related to speaking and listening and implications for pedagogy and student learning. Now let's get to the warm-up. In this warm-up, you'll work with a partner and look at a scientific figure, a diagram or illustration. You and your partner should discuss the figure and decide what you want to tell the class about it. There's no right or wrong answer. Each of you received a different diagram that you must talk to the class about. Take turns showing your diagram and talking about it to the class. As you listen to your classmates, take notes about what each person says about their figure. Now that you've listened to your classmates twice, once in a paired interaction and once in a presentation, get with a partner, someone you didn't work with before, and debrief about the language that was used in both situations. First, think about the interaction you had with your partner about the figure. How would you describe that interaction? Then, think about the presentations you gave and heard. Was this language similar to or different from the language used in the first interaction? If you think the language was similar, how was it similar? If you think the language was different, how was it different? Think about the discourse structures of the paired interaction and the presentation. How would you describe them? What about the sentences, words, and phrases in each? Finally, think about whether this task was easy or difficult and what made it so. The paired interaction might be described as a conversation, whereas the description to the class might be called a presentation. Each is a different kind of speech event with different kinds of rules. You may have noticed that your conversation was more interactive. You and your partner probably each took turns and may have overlapped or interrupted one another. Your language may have been less formal, even though you still used some of the technical terms needed to talk about the content of the figure. In the presentation, the speaker probably held the floor and no one else talked or interrupted. There may have been certain phrases used to signal the introduction and end of the verbal presentation. Some people may find presentations difficult to do. Others may find conversations difficult to navigate. This task was intended to help you think about the different types of talk that may go on in a classroom and how the rules of speaking may differ, as well as the language that's produced. It's important to provide students with opportunities to participate in different types of speech events and to help them understand the differences between them. Not all students have the metalinguistic understanding of different speech events, so drawing their attention to the characteristics and implicit rules can help their language development. Now let's look a little more specifically at the notion of speech events. Speech event is a term that was introduced by a linguistic anthropologist, Del Hymes, and has been used by many anthropologists to look at the ways language is used across different types of contexts. Hymes was instrumental in bringing an anthropological lens to schools and classrooms, and how children are socialized to use language in particular ways. A speech event is an identifiable way of speaking used in a particular speech situation. The format of talk is typically similar across situations, with the same purpose of communication, the same topic, same types of participants, and the same language variety or register. You're already familiar with many types of speech events such as warm-ups, class presentations, discussions, lab activities, and pair work, and you've already shown that you're aware of the unspoken rules of how language is to be used in these different types of situations. Sometimes speech events are so natural to us that we aren't aware of the so-called rules until they're broken. They seem as natural as the air we breathe. It's important to remember this in school contexts where students are often implicitly assessed through the ways they use language. If students aren't aware of the implicit rules of using oral language in the classroom, they may be at a disadvantage. Again, it's very important to support students' metalinguistic understanding of different speech events in a classroom, as well as the types of language expected for each use. So, let's think more specifically about the use of oral language in science classroom settings. Take a moment to write down some ideas about what types of speech events might take place in a science classroom and what the rules are for language use. Beyond the events, characterize how the language might be described. Think about what talking science might mean. As mentioned before, in recent years a number of books have been written about the topic of talking science. Jay Lemke's book looks at talking as a scientific activity. Talking science isn't just talking about science, but it's actually part of the work that scientists do. It's a scientific practice. Some activities scientists undertake can actually be constituted by talk. For example, observing or comparing are linguistic actions. Very little work could be accomplished in science without talk. It's important to remember, too, that scientific communities develop their own ways of talking. Being a full-fledged member of that community requires that one is able to talk science. Another science education researcher, Wolf Michael Roth, also wrote a book called Talking Science. He places talking within a broader array of modalities in science. He argues that students come to understand science through action, gesture, and talk. Conceptual understanding of science in this way actually coincides with physical processes. Roth describes talk as a flexible interpretive process through which students can jointly construct meaning. This means that talking allows students a great deal of leeway in expressing their understandings. As they come to conceptually grasp scientific concepts, students sift through their ideas by talking about them. If one idea doesn't seem quite right, another student can interrupt or overlap with one another and fix that idea by proposing a better term or phrase or way of saying something. Talking is quick and easy, and it's erasable. It affords students meaning-making potentiality. The kind of talk that Wolf Michael Roth describes might be characteristic of laboratory settings, group discussions, and even classroom discussions. This is one reason it's important to include these types of speech events within the classroom. They actually provide a flexible cognitive space for students' conceptual understanding to emerge. With these ideas in mind, we're going to transition to doing a speaking activity that will help apply these ideas and relate them to the articles that you read for today. Talking chips is a Kagan strategy. Get into groups of 4 or 5. The instructor will hand out some talking chips, which might be anything from pennies to Legos to dried beans or paper clips. Each individual will get 6 talking chips. You'll discuss 3 question prompts and you'll use 2 chips for each question. For each question, use one of your chips for original ideas and one to respond to another group member's idea. In the next slide, some questions related to the Roseberry and Ballinger reading will be displayed. For each question, each group member will put in 1 talking chip into the center of the groups with an original response. You'll also put in a talking chip into the center of the group to add on to someone else's idea. Once you've used both of your talking chips for that question, you must wait until each group member has used their 2 chips. The chip strategy will start over when the instructor moves on to the next question. Start with the first question. Describe the type of speech event Roseberry and Ballinger focused on in their essay. Don't forget to place your chip into the center as you share your ideas. Limit yourself to 2 chips per question. When the whole group has put their chips in for that question, you can discuss more organically until your instructor moves on to the next question. Now that you've had a chance to do the talking chips activity, think about how it's beneficial for linguistically diverse students. How could you adapt this activity to use in your middle school classroom? Talking Chips is a specific type of speech event with particular rules to help support language minority students. Language minority students have been shown to speak less in classes than mainstream students. It's essential that all students have the opportunity to talk and voice their ideas and have the cognitively flexible space that supports the development of conceptual understanding in science. Structuring talk like this helps ensure that linguistically diverse students have the opportunity to practice talking in a small group setting where they may feel more comfortable. Also, giving the chips to students ensures that everyone has a turn to talk. This activity could be used in many ways, as a warm-up to talk about initial ideas about a topic, or even as a review activity to go over material that everyone has covered. Now let's dive into the Roseberry and Ballinger article a bit. Take a moment to discuss this quote from the article. What does this quote mean to you? Children come to school fully prepared to engage in scientific activity, and the school, not recognizing the real nature of scientific thinking and discovery, directs its effort toward training those natural abilities out of the children. This quote appears near the end of the Roseberry and Ballinger article. In response to this, the authors write, all children, regardless of their first language or educational background, come to school with rich experiences of the world and ways of accounting for them that can be used as resources in teaching and learning science. A major challenge facing teachers who teach children from different backgrounds is to learn how to recognize the instructional potential of those resources. The type of speech event that Roseberry and Ballinger focus on are called science talks. These classroom conversations are intended to help bridge students' everyday ways of knowing scientific ideas to classroom ways. Roseberry and Ballinger provide the following strategies for working with linguistically diverse students in science talks. First, engage your students in a common activity with scientific phenomena. Next, initiate an open-ended discussion about the event with your students. Listen carefully to what your students say as they share their thoughts, and encourage your students to talk with one another, allowing them to use a range of language styles to communicate their ideas. Act as a facilitator rather than as a teacher of the conversation, and allow the conversation to develop and unfold with as little intervention on your part as possible. Assume that the students understand one another even if you don't yet understand what's being said. Reflect on your students' ideas after the science talk has concluded, and consider meeting with other teachers to discuss the science talk and your reflections. Now take a moment to reflect on the idea of science talks in your notebooks. Write down what you'll remember about this article and how it might inform your own teaching. The other article you read today was a case study from the Next Generation Science Standards. To review this piece, work with a small group or partner to discuss these questions. First, describe the case study, where it took place and who the participants were. Second, what was the teacher's pedagogical approach to teaching? Third, use the graphic organizer to record the speech events the teacher used in the classroom. How did the students listen and speak, and what role did they serve in learning? When you use the graphic organizer to go through the article and record the speech events, they're not directly identified in the article. You'll have to think about what they might be and use your own words to identify them. For example, is there a warm-up, a presentation, etc.? This is an open-ended opportunity for you to apply what you know about speech events to a new situation. Identify the speech event, the topic, and the way that students engaged in listening and speaking. Fourth, what are the main points you'll remember about this study, and what implications of this study do you see for your own use of talk in science settings? Now that you've had some time to talk with partners and go through the article, let's review the case study together. This case study took place in Sequoia Middle School, an urban district with many diverse students. The 8th graders were in Mrs. C's science class. She took a culturally relevant pedagogical approach, asking students about their own everyday experience and relevance using her knowledge of the neighborhood. This mirrors the type of science talks that Roseberry and Ballinger describe. Here are some of the speech events that could be identified from the descriptions in the article. Remember, there are no right or wrong answers to this. You needed to use your own words to identify the speech event, topic, and how students engaged in listening and speaking. There were teacher-led whole class discussions about alternative fuels, where students gave summaries and listened to other students' knowledge and experience. There were whole class discussions about homework, about types of fuel and foods. Students reported findings from their assignment and listened to other students' comments and ideas. There were small group questionnaires about thinking about plants as transportation fuel. Students gave their opinions and other students listened to those opinions. There were teacher-facilitated questions about future investigations, where students asked and answered questions. There were article presentations about ethanol and alternative fuels, where students gave and listened to summaries, and students also acted out models about the life cycle of the matter in ethanol. Students talked and acted out models and tried out new vocabulary, while other students listened to the presentations. This case study illustrated a wide range of speech events that could be used in a science classroom setting. The wide range of speech events used in this particular classroom appealed to diverse learners and also supported conceptual understanding of different content. The teacher used small groups to discuss the life cycle assessment process tool. Students explained and listened to each other's ideas. She also used a multimodal modeling activity and discussion, and even though the teacher primarily talked, students gave explanations at the end with evidence. She also used small group discussions with a roll number so students could discuss thoughts and commit to decisions. They discussed collaboratively and shared their ideas with the class. And finally, students used different ways of expressing learning, such as raps and plays, to think about the most meaningful ideas from the unit, and then they gave presentations to the class. These articles were intended to help you think about the role of speaking and listening in science classroom contexts, working with linguistically diverse students. Take a few moments to think about the main points you'll remember about the Roseberry and Ballinger essay and the NGSS case study. What implications do you see for your own teaching from these articles? We're going to do one final activity today to help apply the concepts we've discussed about speech events and talking science. This is going to be a data workshop where you work with transcripts from actual science classrooms. Get into a group with a couple of other students and look at the transcript that's provided to you by the instructor. These transcripts are from an 8th grade classroom where the students were studying introductory chemistry. These transcripts all come from publication about the students' use of language in a science classroom. Read through the transcript together. You might act it out or read it silently as a group. Then, answer these questions. What kind of speech event are the students engaged in? What are the rules of speaking and listening in the speech event? In what ways must students speak and listen in this activity, and in what ways are they optional? What aspects of scientific language do you notice in the transcript? Underline discourse structures, sentence features, and important words and phrases. Finally, what role does speaking and listening play in learning? Now it's time to wrap up today's class. Think about how you used language in the classroom today. How did you listen, read, write, or speak? What language did you need to know in order to engage in learning? For the next class, the following articles are assigned to you. For the ticket out today, please answer this question. What more do you need or want to know about speaking and listening in science learning settings in order to be prepared to meet your students' learning needs?